So we just got a few more examples I wanted to go over. So for this video, the first set of examples use this direction, and that is name all theta that make the following true. Now, in doing this is kind of different than what we've been doing because now we're trying to actually find out what angle measure is given the ratios. And this is something we're going to learn more about as we go through, but this is kind of our first pass at being able to do this. In these problems, they're going to have exact values that we should be able to spot based on what the possible drawing is of where our xy coordinate would go. So the first one we want to look at is one like this. If the tangent of theta is 0, well, the only way to get 0 is to have as a fraction. Remember, all of these, we know our fractions are sine is y over r, cosine is x over r, tangent is y over x. So the only way to get that is if y is 0 and x has some value. Well, where would y be equal to 0? So what you do is you draw it on the coordinate grid and you think, well, when is y equal to 0? Y is equal to 0 when you have some value on the x-axis. That's when y is going to equal to 0. And so if we think about these 2 points, we could have x, and we could think about them as r, actually is probably a better way to think about it. But the angle measures here are just going to be theta, and we're looking for theta is going to be less than or equal to 360 and greater than or equal to 0 on this one. And so one value that makes it true is that theta equal to 0, right? When we have this line, our coordinate is something comma 0, that's a 0 degree angle. And so when theta equals 0, tangent of theta equals 0. The other place is 180 degrees, right? When even though the r value, the x value is going to be negative here, 0 divided by a negative is still 0, so it can be 0 or 180 degrees. For a second one, we can look at the cosine of theta is equal to 1. Well, if cosine theta equals 1, we've got to think about what cosine is. Remember, cosine is equal to x over r. And so that means that the x value is the same as the r value, which means that the leg is the same as the hypotenuse of the triangle. And the only way that's possible for the cosine of theta to be equal to 1 is if the also, kind of like the last problem, it's on the axis, on the x-axis. And so if this is r, remember that r is the distance from the origin to the point. If on the x-axis, this would be r, which means that our x value would be r. And so when we do the cosine of theta, we get r over r, which does equal 1. Now note, this one is just going to be theta equals 0 degrees. Actually, up here, we could also include 360 degrees in there. I think in your homework problems, it does not include 360, and so I included them here, and so let's go ahead and take that off, and so we don't need 360. So for this one, at 0 degrees works, but 180 does not work because for 180, if this point is r away, then the coordinates would be negative r comma 0. And so the cosine of theta would equal negative 1 if theta was 180 degrees. So we know that 0 degrees is the only possible answer on this one. Okay, another example of this is one that is sine theta equals square root of 3 over 2. Well, sine, remember, is y over x. Sine also, we learned, is positive in quadrant 1 and quadrant 2. And so we could either have it here or we could have it here. And if it's root 3 over 2, that's y over r. And so the r would be 2 and the y coordinate would be root 3. So the same thing over here. Well, if you do Pythagorean theorem, for x, you get x squared plus root 3 squared equals 2 squared, which gives you x squared equals 1. So x equals either 1 or negative 1. And it turns out, yeah, that's what these coordinates are, negative 1 and 1. And whenever you have this relationship of 1, root 3, and 2, that means you have a 30, 60, 90. The y value is root 3, so that means the opposite the angle is the larger of the two sides, so that means this angle must be 60 degrees, which means this must be 60 degrees. So the answer for this one must be theta equals either 60 degrees or 120 degrees. It does not equal 240 degrees, the angle down here, because here the sine value, the y value would be negative, and so sine would be negative, and we know that sine is positive for this problem. All right, and then number two, or another example is one like this, where you have the cosine of theta equals negative 1/2. And so for this one, when we're looking at it, if you've got cosine theta equals negative 1/2, then we know that the cosine is negative in quadrants 2 and 3. And actually, when we think about this, this happens when the r value is going to be 2 and the x value is negative 1, which means that the y value, based on the work we just did, would have to be root 3. But it also works, and so this is a 60-degree angle. So theta equals 120 is one of the answers. But it also works down here because when this is 60, you also get negative 1 negative root 3 instead of negative 1 root 3. And that works because the negative 1 over 2 is negative 1/2. And so we know that 180 plus 60, which is 240 degrees, also works for this problem. All right, so the last set of examples we're going to do look like this. Write in terms of cosine theta and sine theta. One thing that will make your life a lot easier on this one is to remember the basic property that the tangent of theta is equal to the sine of theta over cosine theta. Notice this is saying a positive theta, so we need to make sure that happens. So our first problem would be sine of negative theta. So what does sine of negative theta going to be the same as in terms of sine and cosine theta? Well, we need to think about, well, what does that mean? Sine of negative theta means that it's going to be somewhere between, and theta for these problems, well, it doesn't even matter. It's going to go this direction instead, right? And so if our theta, this angle's theta, well, sine is going to be negative, and so we're going to have some negative value here for our y value, and we don't even know what our x is. And so if we think about it up in this angle, well, we'd have the exact same triangle, except it'd be x over y. And so we think about the sine of theta would equal negative, positive theta would equal y over r, whereas we know the sine of negative theta is going to equal negative y over r. So the difference between these two values is just negative, and so that means that sine of negative theta equals negative sine of theta. Right? Take the opposite of sine theta, that gives you sine of negative theta. One more example of these is if you have a problem like this, the cosine of 180 plus theta. And so again, we draw a picture. Cosine is going to be something like this, and where this is x and this is y. And so 180 plus theta is going to be down here. When you add 180 degrees, that theta reference angle ends up being the same. And so that means our triangle can be the exact same, except that instead of x comma y, we'd have negative x comma y, negative y, and our radius would be the same. And so if cosine of 180 plus theta would just be negative x over r, whereas cosine theta equals x over r. So what do these have in common? Well, they're just negatives of each other. So that means the value of cosine of 180 plus theta is just equal to the opposite of the cosine of theta. So kind of similar to the last one. All right, those are examples from 12.3. There's a lot going on in that chapter, so there's a lot you need to pay attention to. You really need to make sure you know how to do each of these different types of problems.